In this video, we're going to have 5 more math prep test type questions, something you might see on the SAT or the ACT perhaps. And these 5 actually are more towards an Algebra 2 level. Okay, the first question we have is an exponents question. We have -2 to the third power plus 3 to the -2nd power. And really it just comes down to how well are you familiar with exponents, and specifically negative exponents. So the first part is -2 cubed, and I'm sure you know that. That's simply -2 times -2 times -2 3 times, which is equal to -2 times -2 is +4. +4 times -2 is -8. So that's the first part. And then the second part is 3 to the -2 power, and that is not equal to -9. It is not -9. It's simply the reciprocal of 3 squared. So 3 to the -2 is equal to 1 over 3 squared, which equals 1/9. And therefore, since 1/9 plus -8 is -7 8/9, our answer is D, -7 8/9. The next question we have, a factorial question. So hopefully you're familiar with the exclamation point, which is a factorial symbol. If n is greater than 2, then n plus 1 factorial over n minus 1 factorial equals one of these 5 choices. And n, of course, is going to be an integer to make this work better. And again, a factorial, to review, is simply taking the number, let's say it's 5 factorial, and it's simply taking each number times an integer less, integer less, integer less. So this would be 5 times 4 times 3 times 2 times 1, which would be equal to 20 times 3 is 60, 120. Or even 3 factorial be equal to 3 times 2 times 1, which is 6, etc., etc. So this is a more general term. What do you do if you have an n plus 1, n minus 1? And generally when you come to a question like this, sometimes the easiest way is simply to just play it out. So let's assume we have n plus 1. Let's expand this. We would have n plus 1 times the next number in the sequence would be n, because it'd be n plus 1. We would subtract 1 and be left with n. Then the next one would be n minus 1, n minus 2, all the way down to 1. And in the denominator, we would start with n minus 1 as our first term. And we multiply it by the next term, n minus 2, and again 1 less than that is n minus 3, all the way down till we get to 1, just like in these examples below. And if you take a look at the expanded fraction, we have n minus 1 down here, n minus 1 up here. We can cancel those. And n minus 2 down here, n minus 2 up there, cancel those. And in fact, we can cancel everything in here, and all we're left with at the very end is simply these 2 terms, which is n times n plus 1, answer B. Next question we have is the function f of x equals -2 times the absolute value of x minus 4 plus 5. And we are looking for the maximum value of f of x, and more specifically, where it occurs. So one way to approach this, if you're familiar with absolute values functions, is to recognize that the general equation is y equals a to the absolute value of x minus h plus k, and this is the vertex, hk, and a is the coefficient, sort of the stretch, and determines which way this will face. And as you notice, this is -2, so it would face down, and our vertex, which would be in this case the maximum, would be 4, 5, because again it's minus h minus 4, so h is 4. Therefore, the vertex is going to occur at 4, which is the maximum value, and our answer is going to be D, 4. And we can do a quick sketch to verify that. If we plugged in 4, we would get -2 times 0 plus 5. Right here is 4, 5. And then if we went 1 less, we would have 3. 3 minus 4 is -1. Absolute value is +1 times -2 is -2, 3. And then if we went one higher, we would have 5, which would of course come out with the same answer, 3. And we would continue down and have an upside down absolute value v. And again, the vertex is the maximum point and it occurs at 4. Find the next term in the geometric sequence. A sequence is simply several terms in order. A series, of course, is the terms in order added together. But we're looking at a geometric sequence, and the key is geometric. Many of you have seen an arithmetic sequence where you simply add a certain common number to each term. And in this case, a geometric sequence, you're multiplying something to get from here to here, and the same number to get from here to here, and etc. And the trick is recognizing what is the common ratio between these two. So it looks a little confusing, but if we were to change this to improper fractions, it would reveal our answer. So 13½ is the same as 27 halves, and 4½ is 9 halves, and 1½ is 3 halves, and then we have 1/2. And now we're looking for this answer. And what do you notice? Well, you notice the denominator stays the same, 2. And what's going on with the numerator? Well, we're multiplying by 1/3, or we're dividing by 3. 27 divided by 3, 9 divided by 3, 3 divided by 1. So what would happen to the 1? We would divide by 3, and we get 1/3 over 2, which would, of course, equal 1/6. And our answer would be 1/6. And the fifth question in this little Algebra 2 quiz, test prep quiz, we have a survey. It's a word problem. In a survey, we have 30% of students are emphasized, that play a sport. And then 40% of the athletes, so of these students, we take the athletes, and 40% of them play only football. What percentage of students, all the students again, play a sport other than football? And you can try to pick out the percentages and do a bunch of calculations and substitution, but sometimes what I like to do is just draw a diagram. So let's draw a similar, it's almost like a Venn diagram, but we're going to draw, this represents all the students, and it's 30%, so let's pick a number like 100, because that's really easy to work with. So if we had 100 students, okay, and 30% of them play a sport, so let's put the ones that play a sport in here. So that's 30. And let's say, so if 30 play a sport, how many don't play a sport? That's 70 out there. So there's our 100 students. And then we're going to take the athletes, 40% of the athletes play football, which is inside this circle. So 40% of 30 is 0.4 times 30, which equals 12. So 12 of these are going to play football, only football. And what's left? If 12 of them play this, and then out of the 30, how many are left? That means the others must be 18. Must be how many are left that play something other than football. Therefore, we have 18 out of these 30, which means 18% of the whole student body plays something other than football. B.